It's a science course in which we're dealing with facts. But the problem is that the facts we're going to be dealing with are discounted, denied, and possibly even generate certain hostilities in conventional physics. And the reason for that is that these facts were generated by a theory of mathematics that established the physical space that we occupy, our bodies, the atoms, everything that composes our physical universe is constructed in a four-dimensional space rather than a three-dimensional space. And this four-dimensional space is of a certain kind. It's a quantum space that is consistent with what science has known about quantum physics, but didn't understand the geometric implications of what they discovered. And as a consequence, they got it wrong. They got it wrong in a lot of places. And we got it right. We got the data to show that it's right. Einstein said that theory determines what can be observed. By that he meant that what we necessarily see isn't what we observe. That is, we have to understand something before we can actually observe it. For example, we might see this little device as Dave's Magic Pepper Popper, a toy. We might be able to recognize in this transparent film a hydrocarbon composed of molecular chains of vinyl chloride.
The three hydrogen bonds of the vinyl chloride monomer provide covalent electrons without orbital restriction. The hydrogen electrons can take any possible orbital position. This is not true of the electrons of the carbon and chlorine elements within the molecule. Carbon and chlorine electrons are fixed in orbit. The heat of the molecule establishes the hydrogen bond electrons into a common orbit of exact electron voltage, which in turn establishes a capacitance field for the monomer. This field is alterable by infusions of different amounts of nuclear heat. The heat-induced common orbit and its resultant capacitance field is replicated throughout the polymer chain.
We create a capacitance field from the electron, among the electron bonds, more commonly known as electrostatic field. And when we've done this, we've transformed the toy into perhaps a serious scientific device.
The field generated by a capacitor determines the amount of electric energy which can be stored in the field. A simple capacitor consists of two metal plates parallel to and slightly apart from one another. Wires connect one plate to the positive terminal of a battery and the other plate to the negative terminal. As a result, the plates receive equal but opposite charges. These charges create an electrostatic field, which results from the attraction that the opposite electric charges have for each other. A capacitor with large plates and a small separation stores greater electrostatic energy than one with small plates and a large separation. If the electron orbit were like that of a planet, an electrostatic field similar to that of a capacitor could not be generated between the electron and the nucleus. A point-to-point exchange of electrical charges across a separation does not establish an electrostatic field. The exchange must be to a two-dimensional plate, as with a capacitor. A plate is necessary in order to establish the field in three-dimensional space. The point-to-point exchange between the nucleus and the electron, which is proposed by the common planetary model of the atom, could not establish a capacitor field. The model of the electron orbit as derived from the quantum dimension, provides an equivalent of the plate of a capacitor. The model is of a three-dimensional orbit in four-dimensional space. The line of charge of the electron is rotated 90 degrees to the line of charge of the proton. Then the electron line of charge is kinked into curvature to produce an electron path. The plane thus produced is the equivalent of the plate of a capacitor and can generate an electrostatic field between the nucleus and the electron.
We can recognize that the energy stored in the capacitance field is slowly discharged as it lifts the pepper flakes to the film. Okay, now we're going to charge the field generator. And you see that it's registering a temperature originally of 70.3, and then the temperature is dropping as the field generator discharges. It went from 70.3 to 70.0, now it's 69.6. So the temperature that we're measuring is dropped almost a full degree as the field discharges.
The electric current in a normal capacitor continues to flow after the power is shut off, as the energy stored in the field is discharged. The amount of time it takes to discharge the field after shutdown identifies the strength of the field. For a polyvinyl film acting as a capacitor, the energy stored in the field is the heat produced by film resistance to rubbing. This added heat energy is stored in the nucleus, from whence it is transferred to the field. The energy added to the field is discharged by attracting the electrons of the peppers, which cannot be detached since peppers are hydrocarbons and dielectric. The field energy is discharged by moving the peppers against gravity to the surface of the film. As the energy of the field is discharged, the polyvinyl nucleus lose the heat they had acquired from rubbing.
When it's first in that influence, it becomes covered.
You're the inventor of this, and I'm going to have to say that, all right? You invented this device, and you can show with this oscilloscope that this field actually causes a current, because that's what happens when you put that you put the washer on this thing, is that when it becomes negatively charged, what it's doing is there's a current, there's a real small current flow there. Isn't that right? So, and that as the field discharges over a period of time, that capacity to cause the current to flow is reduced. Isn't that what you're showing?
Yeah. Uh-huh. So this is the device for measuring the field strength. The maximum field strength is indicated by the height of a pulse that we have on this screen, and the rate at which I remove it will help it. Well, that's not right, but the rate I'll remove it quickly so that the rate will not affect the charge. The rate of removal will not affect the charge. So right now I'll place this on the film, the washer on the film, and when I remove it, it shows the charge of the film. When we charge the screen, or when we charge the film by rubbing it, there's a triboelectric effect that they say is responsible for charging that. I don't agree, because this charge is on both sides of the film, and the triboelectric is more material specific. So on this particular film is what this particular experiment entails. So when we remove this, it will show a maximum charge. The maximum charge here is 3.5 major divisions. Let's do that again. near 3.5 major divisions on the maximum charge there. When we place this field over the peppercorns, you can see the action of the peppercorns, and the peppercorns are being charged and exchanging charge between the lower part and the upper part. Then we can tell that this has actually happened. How can you tell this happened? By the strength on the field on the film has decreased, and we can measure that amount of decreasing. So you can see as we go down, we see a negative charge happen, indicating that Y shear has become negative. And then as I raise it up, it shows less than a third of the energy that it had, and the peppercorns in that exchange has taken that energy from the film, the capacitance of the film, and Larry has explained how that capacitance organizes itself in the materials so that they react with each one another.
This is functioning just exactly like a normal capacitor.
So in my mind, what's happening is probably that.
Yeah.
But what makes a peppercorn jump?
But what makes the peppercorn jump? We've got to know that. In this question and in its answer is contained one of the most important keys in atomic physics. There's a great difference between the capacitance field, which exists in an electrical circuit, and that generated by the orbital positions of the hydrogen bonds. The most important difference is that the electron bonds, or the orbital positions of the electron bonds, are restricted to quantum distances. Now, what do we mean by that? If one were to examine the periodic table of elements, one would see that the orbitals are established in a set number of positions. They're defined as by shells and subshells. 7 subshells contained within 7 shells, each shell being a further distance away from the nucleus and having a higher energy state. The electron can only acquire these positions. That is, they have got there is no continuum. There is no continuum between these orbital positions. It has to jump from one position to another position. And each one of these positions is established as a specific electron voltage. Now, this is very, very, very significant because it is a fact which has been suppressed by established science.
A quantum dimensional model of the atom gives a table of exact electron voltages for atomic orbital structure. Electrons are distributed into 7 subshells contained within 7 shells as provided by the periodic table of elements. However, this table of exact electron voltages for the shell-subshell structure is disallowed by the uncertainty principle from quantum mechanics. The uncertainty principle has been accepted by consensus. It is true only for mathematically irrational, orbital motion. It is not true for the quantum dimensional model. The table of exact electron volts is not allowed by consensus physics. There is a consensus theory known as the uncertainty principle. It holds that the electron's position in orbit and the electron's energy state cannot be simultaneously known. This alleged principle is true only for the consensus electron cloud model. It is not true for the quantum dimensional model. Yet the more rational quantum dimensional model is forbidden by consensus physics, and neither is the precise table of exact electron volts for atomic orbits allowed.
For our peppercorn jumping polyvinyl stage, this fact of a common electron voltage is very, very critical. That is, the electron voltage of the orbital for the stage has to be exactly the same as the electron voltage of the peppercorns underneath. This means that if we put in a small amount of heat energy into the stage, that we actually increase the field strength of the stage to the point that it can project down and pull the peppercorns to itself. But the point that has to be understood is that if the electron voltage of the orbital positions of the peppercorns and the electron voltage of the orbital position of the stage are different, this phenomenon will not occur. We know this to be the case because if we take the stage and we heat it, for example, with a hairdryer so that it's got a much greater temperature than the peppercorns, it no longer works. The difference between the electron orbital, the quantum orbital position, which has a set electron voltage that can only change by jumps as more and more heat energy is put into the field, is that the capacitance of that field can be actually increased by adding a small amount of additional energy, but less than is necessary to cause the electron to jump into a new orbital position. Over my right shoulder, you see how this standard capacitance formulas operate when applied to the electron orbital capacitance fields. That is, the standard formula of charge is equal to energy over voltage, that if the voltage is held constant, which would not occur in an electrical circuit, but does occur in the orbital capacitance field, then when the energy is increased by a small amount, without affecting the voltage, the charge also has to be increased. And the second formula, that is capacitance is equal to charge over voltage, that if the charge is increased in a voltage field that has to remain constant, as with the electron orbital, then the capacitance strength also increases. This is never observed in the electron, the electrical circuit capacitance fields because the voltage is never able to be held as a constant. In summary then, we used a small, almost toy-like device to demonstrate that the fields produced by the hydrogen bonds of polyvinyl could be significantly increased in strength by simply applying a small amount of heat energy into the film. And then we demonstrated that this field that we so generated, that was able to pull these peppercorns a half an inch from below to the surface of the film, that this field was very similar to the capacitance field in an electrical circuit, but that it had one great difference, and that was that the capacitance field generated by the electron orbitals are of a fixed electron voltage and are not a continuum of voltage as in the capacitor in the electrical circuit. What we are going to demonstrate is this capacity of the capacitance fields generated by the orbitals of electrons, that this capacity to be able to increase the strength of this field has led to a discovery that ultimately suggests the possibility of a new form of nuclear energy when applied in a different context.